here we go again. I said I will change my thermostat and I sure will do it. But I don't just change my thermostat. I have to study actually what the consumption is and what the impact of the engine temperature is for the engine if I run it hotter. And now I have bought a stock Walter or something like that, 87 Celsius TDI thermostat, which belongs to this engine, 1.4 liter TDI. And then I have bought two thermostats which are 92 Celsius and one thermostat which is 105 Celsius. And now I'm testing what the idle consumption and the consumption with neutral RPMs are with different temperatures. At idle 2000 and then from 90 even 3000 RPMs. And now I have built there a stopper so it's easier to control the RPMs. And I have taken the radiator fan out so it will not start. Normally it starts at 97 and now we are already at 108 Celsius. The car's original thermostat meter or temperature meter still shows that there's no problems with the engine, so I would guess there is still no problems with the temperatures either. So let's rev it a little bit to the 3000 and get the consumption reading. This is the last reading I will do, or the last temperature, at least at this time. So I try to get it to 3000. There's 3000. There's 3000. And now the temperature gets higher and higher. And when it's at 110, I take the reading of the fuel consumption liters per hour. It might go to 0.7 with good luck. There's 0.7. RPMs drop a hint. Need to push a little bit back up. Okay, there's 110 Celsius and it's 0.7 liters. So, what it has done, when the engine temperature was cold, when I started the cold engine, the idle consumption was 0.5 liters, 2000 RPMs, 1.1 liter. Then it started to go down. At 50 it was already 0.4 liters at idle and 1 liter at 2000 RPMs. At around 80 Celsius it dropped to 0.3 occasionally, not all the time. It was fluctuating between here and this. 2000 RPM consumption was already 0.7 liters. Around 93 or 90 Celsius I started measuring at 3000 RPM, then it was 0.9 liters. And here the idle consumption was already 0.3 liters and fluctuating between 0.3 and 0.4. When I put the lights on it went to 0.4 and jumped sometimes 0.5. At 2000 RPMs already 0.5 and 100, not much difference in these lower values. But then again at 3000 RPMs the crank is rotating much faster, so it has to push through the oil, and that's why it's creating more stresses or consuming more fuel. And now at 110 Celsius we were able to get 0.7 liters. But the idle consumption is still jumping between 0.3 and 0.4. So there's no difference. When I put the lights on, there it stays then more in the 0.4, 0.5 sometimes. And this torsion value impacts that consumption a lot. It's also jumping a little bit, so it impacts the consumption also. That's probably the main reason why the consumption is not stable all the time. If I put the lights off, then it should start to show the 0.3 again. So the conclusion is, the hotter your diesel engine temperature is, and faster you can get to your operating temperature, no matter what it is, the lower your consumption will be. And now I will do this kind of hack. I think I will first test on water with all the thermostats I have bought. What are the opening temperatures? But my car is not overheating even when there is no actual fans running. And as you can see, it sits nicely at 110 Celsius. Original meter still shows no problemo. I might even try the 105 Celsius thermostat, depending how it opens on my test, to get huge boost in my consumption. Now my thermostat is broken, so it should be fully open all the time. So we will see. But I think this is the best test proof what the impact of the engine temperature is to your consumption. On road testing, the impact is not so visible because there's wind, there's everything else. So this is the way to test what the impact will be. And it's clearly showing with higher stresses the consumption is going down. And even lower stresses up to 90 or 80. From 90 the idle consumption didn't go down anymore. I might see maybe 110 consumption at 2000 RPM, might be 0.4, but let's see.